Okay, so moving right along with Mr. Coy and his storage buildings. At the top of page 664, we're going to take a look at another problem here. So Mr. Coy is building more storage buildings. He wants to know how the areas of the buildings are related, or finding a pattern. How does the area change from the area of building E to the area of building F? And how does the area change from the area of building G to building H? All right. So let's come down here. What do I need to find? Okay. So the first thing you'll need to find, I need to find how the area will change from E to F and from G to H. It's almost exactly like the problem in the first one. Okay. What information do I need to use? I need to use the length and width of each building to find its area. And how will I use the information? By recording the area in the table. Then I will look for a pattern to see how the areas will change. How am I going to do this? Well, complete the table to find patterns to solve the problem. At this point, if you need to hit pause so you can get that stuff copied in, you go right ahead. All right, we're going to look at buildings E and F, and we're going to go ahead and use red here so that we can kind of keep our data straight and organized. So building E, when we looked up here, all right, we have a length of 5 and width of 8. Okay, so 5 by 8. So right here, it was 5 foot. And right here, we had 8 foot. And because we were all very proficient, quick with our times tables, we know that length times width, or 5 times 8, is going to give us 40 square feet. So there's our first building right there. Going back up to our diagram up here, we have a 4 by 5. Okay, so the 5 is the same, but we went from an 8 to a 4. All right, looks like we went halfway. I bet that's going to be very important later on. So the 5 foot stayed the same, but we went to a 4, which is going to take us to 20. All right, because 5 times 4 is 20. And then right here, 5 times 8 equals 40. All right. All right, well, let's progress to the next buildings here and see what we can't figure out from there. Right here, we have a 10 by 8 and a 10 by 4. So the 10s are the same, and we go from an 8 to a 4. So right here, let's go 10 foot. And then this was 8 foot. And 10 times 8 is going to give us 80 square feet. So length times width, 10 times 8 gives us 80. And then it was, let's go ahead and get these copied. There we go. Instead of an 8, this was 4. So instead of 80, we will have 40. All right, 10 times 4 will give us 40 square feet. All right, so we've got this good information here. So what happened from 8 to 4? Well, from right there, we halved it. All right, so that is going to go half. Well, when we went with half from 8 to 4 right here, well, our area also went half. And the same thing could be said over here. From 8 to 4, that was half. And when we went halfway, from 8 to 4, our area also was halved. All right? Or we could say that it was divided by 2. All right, because 8 divided by 2 is going to give us 4. 40 divided by 2 is going to give us 20. All right, same thing over here. 8 divided by 2 is 4. So 80 divided by 2 is going to give us 40. So how did your table help you find your pattern? Well, it might include something like this. I was able to see if one side changed by half. So if one side changed by half, then the area would change by half. Okay? So there is the second example.